X cubed plus 4x squared minus 5x. Whoa, finished. Minus 2. Okay, now if I were you, I got it graphed right on my calculator. I'd go to the graph and then I'd hit the trace button. Now, there are 8 numbers on screen right now that you need to try. Find me something that works. So, type in a 1. Did that work? When you typed in a 1 and hit enter, what did you get? I mean, when I plugged in a 1, I got 0. Isn't that a good thing? Hey, that means we found one of them. That was pretty quick. Alright. Find any more? -2? Okay. Now, suppose we didn't know what the last one was. Suppose it wasn't rational. What could we do with each of these things? Synthetic division. Great answer. I love it. So we're going to plug in a 1. We got a 3, we got a 4, we got a -5, and a -2. What are we going to do with the 3? Bring it down below the line. It always drops down below the line. And then you begin your process. Multiply, add, multiply, add, multiply, add until you get it done. Multiply, add, multiply, add. Oops, sorry. That's a 2. Multiply, add. Am I supposed to get 0? Yes, because it's the remainder, right? You don't get 0 down there, something went wrong in your synthetic division. Unless you accidentally, you know what, I've seen kids put the wrong sign. They put -1. They meant +1. They put -1. They end up with a, that should be telling you, oh, something's wrong, I need to go back and check. All right, now, keep going, but use the next number. Bring the 3 down and keep going. Multiply, add, multiply, add. We didn't go back to the beginning, folks. We kept going with our synthetic division. Now the question is, what in the world am I looking at? Here's my remainder down here. What's after the remainder? Move from right to left. You got your remainder. What's after the remainder? What does that 1 represent? Because if you can't interpret it, I don't know. What do we call it? Starts with the letter C. Constant. Thank you very much. It's the one that doesn't have an X. Okay, then what's after the constant? The linear term. Folks, remember, it goes up in powers. Linear term, quadratic term, cubic, quartic, quintic. Now, we need to know when this is equal to 0. Can you solve that? Do you know how to solve that? Should be fairly easy, right? Subtract 1, divide by 3, which is why you were correct when you said -1/3 as the final solution. So, now the nice thing was, all of those appeared nicely on screen. What if they don't? What if I only have 1? Or what if I have 1 that's nice and the other 2 are ugly? Well, then we have to use quadratic formula or something after that. We did not have to do that here. Yep.
Why is it why aren't the 1 and the -2 mutually exclusive? Why do they transition into each other?
Well, what we're dealing with is the original polynomial is based on this. That's the original polynomial in factored form. So what we were doing by taking the 1 and the -2 off the graph is we were then breaking down or dividing the polynomial into smaller pieces. So when we first took out the x minus 1, which is the green part up there, what were we left with? What is this thing right here? This is 3x squared plus 7x plus 2. But since we had another factor already from the picture, instead of trying to factor that or hit it with the quadratic formula, which we could have done, we went the easier route. We thought, hey, let's just keep going with our synthetic division and continue breaking it down until we get to something that's a lot easier to solve. So we got it all the way down to a linear factor. That's the easiest thing of all, is getting it down to a linear factor. Because, basic algebra 1 type stuff where we subtract and divide and we have our last answer. Okay, let's do it again. Alright, so we need factors of 8. What goes into 8? 1, 2, 4, what else? 8. Okay. How about factors of the leading coefficient? 1 and 2. If we take these 8 numbers and divide by plus and minus 1, what does our list look like so far? Well, it's pretty much plus minus 1, plus minus 2. Oops, I can't even write. I can speak but not write. Plus and minus 4, plus and minus 8. So here's my question. When you move over, you take the same 8 numbers, but this time you divide by positive and negative 2, are you going to be adding any new numbers to the list? How about 1 over 2? Is that adding to my list? Yeah, that's a new value. How about 2 over 2? That is not a new value because we already have 1. How about 4 over 2? Is that adding anything new? No. 8 over 2? Still no. So sometimes you are adding new values to your list, but sometimes you get these repeats in there, so you're not adding more. So we really have 10 possible rational values. Okay, graph it. You got your calculator, graph it. Did I get a beautiful picture? Did I get a beautiful picture? No, good answer. But is there enough information on this screen right now to give me what I need? I mean, are they going to ask me for relative mins and maxes? No. What are they asking me for? intercepts. I want to know where it hits the x-axis. I can see 4 of those on screen right now. I don't really care about changing the window. Okay? So find me. You got 10 numbers to plug in there. Hit the trace button, start typing in these values, and find me something that works. Question was, why don't I just use my graphic calculator to find all 4 solutions? Number 1, some of them might be irrational solutions, for which you would be giving me some ugly decimal for no good reason. 2, this would be more likely to be a no graphing calculator question. So for instance, in order to do something like that, I'd have to actually give you the picture. Then you would know, oh, I got these 10 numbers. I can look at my graph and I can kind of see, oh, hey, I think 4 looks like 1. Does 4 look like 1 on your picture? It sure is. So on your picture, you should see 4 and what else? Negative 1/2. Okay. So you should see those 2 on your picture. Pretty easily. All right. Synthetically divide 4. We got a 2. Do I have any missing terms that I have to put in a 0 for? Any missing terms that I have to put in a 0 for? Yes or no? No. So I'm good. I just needed to check it in case that comes up, because that would be a showstopper right there. Okay, do your synthetic division. End up with a 0 for the remainder, otherwise we didn't do it bad. Get a 0. I hope we did. Now, you know that negative 1/2 is also a 0. So keep going. Keep going. Don't stop believing. Hold on to this feeling. Yes and no. You still have to factor the remaining piece. Or solve it. Or use a quadratic formula. Something, because you started off with a quartic. You took out 2 linear degrees. That means you have to be left with a quadratic at the end. If you're struggling with the synthetic division, remember you carry down the first one. Always gets carried down. Don't carry that one down, or it'll mess everything else up. Okay, anybody else? start getting into those fractional values, you have to be careful. So, but we could have, yes, you're exactly right. Okay, so what did we just find? What is this 2, 0, negative 4 thing? If that's my remainder, what's the thing next to it? That's the constant. What's the thing after that? That's the linear. What's the thing after that? That's the quadratic term. Okay, so when does this equal 0? Do I need to use the quadratic formula on this? No, the answer is definitely no. I do not have to. Could I? Yes, I could if I wanted to. But there's absolutely no reason I need to. Alright, now what? Since there's no linear term, I don't have to use a quadratic formula. So, solve it. Does anybody know how to solve that? Add 4. Okay, that's good. 2x squared equals 4. Next. Divide by 2. Divide by 2. So that means x squared equals 2. Take the square root. What do we end up for the final two solutions? Plus and minus radical 2. I don't really care if you leave it like that, but there should be 4 total answers here. You found 2 of them on the graph. 2 of them were rational. Which 2 are rational? Negative 1/2 is rational, yes. 4 is rational, yes. Rational means you can write it as a fraction, yes. Okay. Without being a genius, is that what you're saying? Unless you recognize it, like for instance, radical 2, do you recognize it as 1.414? When I was in school, I kept seeing 0.866 all over the place. That's radical 3 over 2. That comes up in trig next semester. That comes up in your right triangles in geometry. You know, those special right triangles. But I would see 0.866, and I knew they were talking about radical 3 over 2. So without memorizing certain decimals, like 0.707, that's like half of 1.414, which means it's radical 2 over 2, which went with my 45, 45, 90 right triangles. I guess in short, the answer is no, unless you've memorized certain popular decimals, you know, that go with the famous radicals. Probably not. Okay, here's a good question for us. For the following, find the function p defined by a polynomial of degree 3. Okay, so we know it has to be degree 3. It has to have real coefficients. Good, because I really didn't feel like doing imaginaries. That satisfy the given conditions. Okay, so we've got 3 zeros listed. -3, -1, and +4. And then they throw in a leading coefficient of -4. Let's see if we can do this in factored form first. So, any ideas what any of these parentheses should have in them? I think you mean something different. I think you got the right idea in your mind. We know that x is equal to -3, x is equal to -1, and x is equal to 4. We need to translate those into factors. See, that's, I knew you were saying, I knew you were thinking the right thing, man. I knew you had it in there. It's okay. And then x minus 4. So that is almost correct with the exception of this. Because currently, the way we have it written, we've got a leading coefficient of 1. Any thoughts on how we could change that leading coefficient to a -4? How about we just multiply by -4? Okay, now that right there is called factored form, but what if I want it in standard form? What do you have to do with all that stuff? Oh, we got to multiply it together. Oh, Man. Yeah, you'd have to multiply it all together. It really doesn't matter in what order you do it. Take your favorite ones to multiply together. If you don't like boxes, shield your eyes. Sorry, some people don't like them, man. There's a real hatred out there in the world towards boxes. Okay, which is why those people will never work for Amazon. Okay, so x squared minus 3x minus 4. Sorry, you can FOIL this however you feel like it, as long as we end up with the same answer at the end. It really won't bother me one way or the other. If you like drawing arrows, then be my guest. Draw arrows. Or connect them however you want to. Ooh, look, those cancel out. So that is, I got a -4x cubed, a minus 13x, and a minus 12. So it looks like my grand total is -4x cubed. Sorry, I'm going a little fast here. 52x and a positive 48. It's just foiling it. I'm sure you're all more than capable of doing that with your own method, whether you like the box or hate the box. It's up to you. It doesn't bother me one way or the other. Any homework questions we need to look at that you were working on this weekend and just wanted to go over because it wasn't making sense? Any of these? Yes. 19. Use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. Okay? Well, we could do some sort of division, couldn't we? What kind of division would you like to do? I mean, it doesn't say that I have to use the remainder theorem, right? Because if I had to use the remainder theorem, let's just say it did say I had to use the remainder theorem, what would you be using from this and plugging into every single x if it was the remainder theorem? You'd be plugging in a 0 value of 1. So that wouldn't be hard. If we had to do it with the remainder theorem, they didn't ask that, but if they did, you would obviously be plugging in 1 to the third, minus 1 squared, plus 1, minus 1. You'd figure out what that was. But if you want to use synthetic division, it's okay, because they didn't specify I had to use the remainder theorem here. We don't have any missing terms to worry about, do we? Like 21 down here, there's a missing term. I would definitely pay attention to those kind of questions, because if there's a missing term, what do you got to put in there for the squared term? 0, so don't forget about that. 1, negative 1, 1, and negative 1. Well, factoring is another word for division. Okay, so if you can divide them, what are we looking for? When we do this division, what are we looking for? We're looking for the remainder of 0. And if we get the remainder of 0, we know the answer is yes. It is a factor. If we get anything else, then we know the answer is no, it's not a factor. Okay? Is there another one that I should put on my list? Is there another one that you worked on this weekend that I should put on my list? Or do you need to make your own list? 24. Okay, I did ask for the odds, but it's okay. So you'd be doing the same thing. Oh, are you kidding me? What kind of cruel person are you? Seriously, look, you just wanted to. Oh man, I hereby solemnly swear I will never skip the 5th, 4th, 3rd, 2nd, and linear term powers in order to screw with your minds. Okay? Seriously, what kind of person does that? Okay? That would be awful. Okay? Now, would that be a better question with the remainder theorem or with synthetic division? I think it would be easier with the remainder theorem because you don't have to skip anything. You just plug in -1 into that polynomial. Seriously. You got me. You got me on that one. I wasn't paying attention. Go back and watch that video if you didn't watch the other one. And